Okay, so today we're going to do how can I use trig functions to find sides and angles of right triangles. And the first thing that we're going to look at is the Pythagorean theorem. All right. Okay, so the Pythagorean theorem says a squared plus b squared equals c squared. And c is always the hypotenuse. So if we were to construct squares around the sides of the triangle, like what we see right here, if you have this side a, well, a squared would make this whole square. This side b would make this square b squared, and c would make c squared. So if I want to find the area of a, well, then I know that it would just be this area, a squared, plus, what's the area of the small box? 64, because 8 squared is 64, equals the area of this giant box, 144. So the area of A is 80 centimeters squared. And so that's how we can use Pythagorean theorem to break down into these squares. Okay, let's look at trig functions for right triangles. The SOHCAHTOA. All right, SO stands for the sine of x is equal to the opposite sine over the hypotenuse. CA is the cosine of x, is the adjacent over the hypotenuse. And the TOA is that tan of x is the opposite over the adjacent. Okay, so if I look at a triangle that has degrees x degrees and y degrees, and sides A, B, and C, then I can set up ratios for each of these angles. So I know that the sine of y is equal to, so the sine of y, sine is opposite over hypotenuse, so the opposite of y would be b over the hypotenuse c. So the sine of y is b over c. This the cosine of y, what would the cosine of y be? It's the adjacent over the hypotenuse. What's adjacent to this angle? A. Right. So this is just a over c. And the tan of y would be the opposite b over the adjacent a. Okay, so now do the sine, cosine, and tan for the angle x. Okay, so you should have that the sine of x is a over c, cosine of x is b over c, and the tangent of x is a over b. Okay, so if we're trying to solve trig functions, after making sure that our mode is in degrees, if we're given two sides and looking for an angle, so we're going to do 3 examples of this, we have to decide which trig function to use, and then use inverse trig functions to solve. So in example 1, I have a right triangle with an angle y that I'm looking for, and I've got the sides 2 centimeters and 10 centimeters. So the first thing I have to do is decide which trig function am I going to use. Okay, yeah, I'm going to use cosine. Why would I use cosine? Because for this angle, I have the adjacent and the hypotenuse. So I think back to SOHCAHTOA, adjacent and hypotenuse, that's cosine. So I go, okay, the cosine of y is equal to the adjacent over the hypotenuse. Now I'm going to use the inverse. So the inverse cosine of 2 over 10 will give me y. Alright, so we're going to say that y equals 78.5 degrees. Okay, in example 2, we have the sine of x is 3 over 7. So anytime that I'm not given a picture, the very first thing I want to do is draw a picture. So I have some right triangle. It doesn't matter where I put x, so I'm going to put x over here. Now the sine is 3 over 7. So where is that 3? Is it over here on this side or on the bottom? Or across the hypotenuse? Since sine is opposite over hypotenuse, it needs to be opposite the x. So this side right here. So we have 3 over 7. Opposite over hypotenuse. Well, since that's already set up, the sine of x equals 3 over 7, I can solve that by the inverse sine of 3 over 7 is going to give me my angle x. Okay, so x is equal to 25.38 degrees. Finally, the last one that we're looking at is that the tangent of x equals 0.259. Well, let's draw a picture of that. Here's x. Now, 0.259, tangent is the opposite over the adjacent, right? But we don't see anything that this is over. But what is this 0.259? What could I divide this by? And it'd still be the same thing. 1. So I'll set up 0.259 to be my opposite, and my adjacent will just be 1. So since the tan of x equals that, I can say, okay, then the inverse tangent of 0.259 will give me x, and x will equal 14.52 degrees. Okay, so our other cases, if you're given one side and one angle and you're looking for a side, let's look at cosine of 42 equals x over 7. So I don't know that side x. I'm going to draw a picture of it because I just want to see a picture. That helps. So if this is 42 degrees, cosine is adjacent over hypotenuse. So my adjacent is x, and the hypotenuse is 7. So now that I'm solving this, if the cosine of 42 equals x over 7, I can find the cosine of 42 degrees using the calculator. If I'm solving for x, all I have to do is multiply both sides by 7, and the 7 in the denominator would go away. So 7 times the cosine of 42 degrees will give me x. So here x equals 5.2. The sine of 78 degrees equals 9 over y. So I draw my triangle. 78 degrees. Sine is opposite over hypotenuse. So this 9 is going to be opposite the 78 degrees. And the y we don't know. That's our hypotenuse. So 9 over y. Whenever I'm solving something like this, I'm not just multiplying both sides by y. I mean, really, that's what you're going to do. You're going to multiply both sides by y and then divide by 78 degrees. So if your variable is in the denominator, all you have to do is swap these two things. So y equals 9 over the sine of 78 degrees. So this the hypotenuse of this triangle would be 9.2 units long. If I don't give you units, you can leave it like that. All right, finally, I've got the angle is 32 degrees. I've got this side x and a side 8.75. So for this triangle, what's the trig function I'm going to use? I have to use tangent because tangent is the only trig function that doesn't involve a hypotenuse. And I don't know anything about the hypotenuse here. Okay. So the tangent of the angle, 32 degrees, is equal to the opposite, 8.75, over the adjacent. So again, just like the last problem, x will equal 8.75 over the tangent of 32 degrees. And the length of this side right here will be equal to 14 units long. Okay. And that's how we'll use trig functions to find angles and sides of right triangles.